here. The average rate of change has to give us 2 points. The rate of change, and we determine the slope. The rate of change is W prime of t. Do not confuse the average rate of change with the rate of change. The average will be a number. The rate of change is a function. So please remember that. So W prime of t is ugly, right? So this is 0. I'm going to start correctly from the degree. So I have to multiply all this by 3. Let's see what I get. 4 and 2, 15, 7 and 1, 21, 22. Okay, and let's see how many zeros here. So 2 more zeros. It's not clear. I'm going to write it again. Sorry. I'm going to erase that. I'm going to erase that. Don't write it. Okay, t squared minus, what do I have? 2 and 1, 9 and 1, 1, 1 and 0 point. Okay, and t, and then plus, correct my numbers anytime. If there is an error, please let me know. And I'm going to get rid of this, not to confuse anyone when I post this. So let me know if my numbers are correct. Should I do the numbers again, or are they?
Where did the 8.15 go?
What is the rate of change of a constant?
Oh, so we don't have to put it because it's the same. It doesn't change. Oh no, a rate of change is 0. I knew that. Never mind.
No worries. Are my numbers okay, everyone? No one says anything, so I'm assuming I'm correct. Okay, this was part A. Part B. The weight of a boy at age 10 months. The weight, not the rate of change of the weight of the boy at 10 months, but the rate of change of the weight at 10 months. And then the rate of change of a boy's weight with respect to time at age 10 months. So what is B and what is C all about? Or are they all about? Can anyone tell us what is B asking us to do and what is C asking us to do?
To find it for what it's expected at 10 months.
Right, so what do I write?
Would you use the initial equation, not the...
Absolutely. W of 10. What are we asked in part C to determine?
I can't remember what the whole thing said for C. I'm sorry.
That's fine. The rate of change of weight with respect to time at age 10.
Is that when we put 10 into the equation we just made for part A?
Very good. That would be W prime at 10. Awesome. So I'm going to share my screen, go to the calculator, and my computer is almost getting out of juice. 1 second, sorry about that. Okay, so go to the calculator and let's plug in. Clear. I'm going to plug in the function first. So 0.30758 x to the third, and then minus 0.0596 x squared, and plus 1.82 x, and plus 8.15, and I'm going to put in the derivative, 0.002274 x squared and then minus 0.1192 x, and then plus 1.82. And then second and table, I will just plug in exactly what I want. And here they are. I'm going to copy 2 decimal digits, 21.15, and the other one, 0.86. Now the big thing is the measurement unit. So, measurement units, please.
I can't remember if they use pounds or kilos, but whatever would be that
Pounds.
over months.
Pounds.
Pounds. So pounds over months.
The weight
Pounds per month.
The weight at 10 months.
That would just be pounds.
Very good. Now, the rate of change of weight with respect to time at 10 months.
Pounds per month.
Very good. Excellent. Please remember the rate of change is will always have 2 measurement units. Always. I will never tell you that I drive at 60 miles. No, because this is the rate of change of distance with respect to time. I will tell you that I drive at 60 miles per hour. Okay, perfect. We touched up on absolutely everything here. And now I would like to continue with 2 more very powerful.
That
Yes.
one's not the one you want us to send in?
Not yet, right now,
Not yet,
in a
okay.
couple of minutes. Okay, so in 1.6, we're going to look at 2 rules: product and quotient rules. Product and quotient rules. I will present them in a certain way. You can twist them around. If somebody else wants to use a slightly different formula, that's fine too. I'm fine with it. Use the one you like. I'm flexible on this one, but just make sure that you use the correct method. So what does this mean? Well, it's a product of 2 functions, and we want to differentiate. So here is the rule. First function prime multiplied by the second one that is not differentiated yet. Just the original function plus the function f times the derivative of the second one. I like to keep them in this order. You can twist them around if you want. You can twist these around, that's fine. But be careful not to mess them up. So I keep 1, 2, 1, 2. 1 prime times 2 plus 1 times 2 prime. You can do whatever you want. So this is the product rule. Product. And now the quotient rule. When we have a function over another function, I keep the same sequence. 1, 2, 1, 2, but with minus. There is a minus now. Exactly the same thing, but with minus. F prime g minus f g prime. The denominator is only squared. There is no derivative in the denominator. So the same formula, if you want to keep it like this, it's the same, but with minus. With 1, 2, if you want to remember it like that, it's 1 prime times 2 minus 1 times 2 prime over 2 squared. It's up to you. That's all we need to do in this section. We just need to practice now. So on page 162. Again, I'm choosing examples so I can help you with the homework, so it doesn't take a long time. As long as you do these problems again, you will be in perfect shape. Okay, again, as I said, very few problems are nice in this book. I'm not sure why, but anyway. So 3 the square root of x plus 2 and times x squared. They want us to multiply and differentiate, and they want us to use the product rule and differentiate and show that it's the same thing. Okay, for now, I'm just going to differentiate using the product rule. This is my function 1. This is my function 2. So here's the rule. 1 prime times 2 plus 1 times 2 prime. So y prime. This is ugly, but we already know the derivative of the square root of x. What is the, that's why it's so useful. If you ask me, what do I do with the cube root of x? I can.
Is that x to the 1/3?
You mean this one? This one?
Yeah.
Yes, exactly. Here, I don't have a rule. I have to do it step by step. But we do have a rule for this. That's why please remember it. So can anyone give us the derivative of this one? Of course, I have to have a 3. And what is the derivative of the square root of x?
1/2 square root x.
Very good. Awesome. What is the derivative of 2?
Yeah.
Of course. Times the second function. So this is this piece. Now I have to multiply by the second function. Plus. So this I have. No plus. I'm going to write the first function without touching it. And now I'm here. I want to differentiate the second function. Can anyone tell us what it is?
The 2x.
That's it. Done. You don't need to simplify this any further. I'm fine with it. Let's practice a quotient rule. Any questions on this? Anyone? Okay, so let's look at a quotient rule. Something like 19. Still on the same page, 162. Yes, these problems are easy. They're easy because we work on them together. So they do require work, meaning practice, please. Okay, so this is my 1 and this is my 2. 1, 2. So now I apply this formula. 1 prime times 2 minus 1 times 2 prime over 2 squared. Okay, so y prime squared. The top prime. Can anyone give us the top prime? And I'm going to write it here. Don't look at the denominator, just the numerator.
minus 4.
The top prime.
2t.
2t. Is that okay, everyone? Because 16 prime is 0.
Yes.
Perfect.
Yes.
Times, so I just completed this piece. Now I have to multiply by the bottom function. Now I reach the minus symbol. Then I'm here with the first function, the top. Times. Finally, I'm here. The derivative of the denominator. Can anyone differentiate the denominator? Just the denominator and tell me what to write.
Is it t?
So we differentiate this. The derivative of 4 is 0. What is the derivative of t or the derivative of x?
Would be 1/2 t.
1. Just 1.
1, just 1. So
Right. It's the slope of this line. So the slope of the line is 1. If I have 2t plus 4, the derivative of this will be 2, because the slope of the line is 2. But here I have 1. So it's times 1. I don't have to write anything. At this point, I will distribute. Please, I'm begging you, I'm going to erase this. Do not write it. I'm not going to even write it. So I've seen students do this. You cannot. T plus 4 is not a factor. It's not a common factor at the top. Do not make that error. You cannot simplify.
Is that just because you haven't finished this? Like, not that you would have to do it.
It's
but like
not a factor. It's not a
Okay.
factor at the top. You could say it would be if you factor this. Yes, but then I will have to factor out, etc., etc. So I will be able to simplify it, but only if I notice that this is factorable. But let's say I don't notice. Let's continue. 2t squared plus 8t minus t squared and minus 16. Everything divided by t plus 4 squared. Continue. 2t squared minus t squared.
Excuse me?
Yes?
I don't know. I don't mean to be rude, but wouldn't this be easier if you look at the top? We can cancel out some stuff.
You could simplify from the beginning. Yes. The exercise, you're absolutely correct. Because this is t plus 4, t minus 4. You simplify and you get t minus 4. I completely agree. But this was an exercise on applying the quotient. Yes. If that is possible, you should always do it. Absolutely. But this was an exercise in using the quotient rule. Absolutely.
I know, but I mean, we can do it in the derivative.
Yes.
Too.
Yes.
Why derivative?
Yes, you can simplify it. I completely agree. We're going to get the same answer anyway in a minute.
Okay.
Of course. So 2t squared minus t squared, this is t squared, plus 8t, correct? Make sure. So I was just talking and I wasn't paying attention. So negative t squared and plus 16. So plus 16 divided by t plus 4 squared. And the numerator, please notice that this is indeed t plus 4 squared over t plus 4 squared, which is 1, but of course t does not equal negative 4. Otherwise, it's not 1. So what we just noticed is that if we factor t minus 4, t plus 4 over t plus 4, I have to still write this. I simplify 1, 1, and I get t minus 4. And when I differentiate, I get 1, exactly what I got before. So again, yes, always simplify the function, no matter what. But this was an exercise in using the quotient rule. So I'd like you to upload this so I can see that you wrote step by step and you applied the quotient rule. Or if you want, we can work on another problem.
Can you bring the bottom up just a little bit? Okay, you're just showing that if you broke. Okay. The bottom part where you have y equals 2 minus 4 times 2
You don't have to write this.
I don't have to write that part. Okay.
No, this was noticing that the function is factorable and it would have made our life easier, but we wouldn't have used the quotient rule.
Gotcha. Okay.
Okay. Let's take a look at a word problem, and I would just like to talk about something called the average cost, average revenue, average profit. And after that, I'll stop, I promise. Let me see how I'm on time here.